Hello everybody, welcome to the video. Today we're going to be going over the law of sines, which deals with finding angles and side lengths in non-right triangles. So a trick can be used for that too. So here we have two acute angles and an obtuse angle, and what we're going to be doing is learning how to find the missing side lengths, like these two for example, and missing angles. So I want to talk a little bit about what the law of sines is and where exactly it comes from. So here we have a triangle, ABC, and generally angles, the variables for angles are usually in uppercase, and the variables for side lengths are in lowercase. And notice that the side lengths across from the angles have the same letter, like AA, BB, and CC. So I want to talk about where the law of sine comes from. Suppose that I draw a perpendicular line here, let's call that H, from A to BC. We know that it's true that the sine of B is equal to the opposite side, which is H, over the hypotenuse, which is C. That's based on SOHCAHTOA. We also know that the sine of C is equal to the opposite side H over the hypotenuse B. So with a little bit of algebra here, including multiplying both sides by C for the first equation and B for the second equation, and canceling things out, we see that C times the sine of B and B times the sine of C are both equal to H. So what that means algebraically is we can set them equal to each other to get this expression right here. So this would be equal to this, and then we can divide both sides of the equation by C and B in order to get the law of sines. So this is what the law of sines says. So if you have the sine of an angle divided by the opposite side, it's equal to the sine of any other angle divided by the opposite side. And the same works for A too. So this is exactly what the law of sines is. The sine of any angle over its opposite side is the same no matter what the angle is. So let's put this into practice with this example 1. We're going to be solving the triangle, and this is a case of angle, side, angle. So we're trying to figure out this angle right here and these two. And actually, without using the law of sines, we can figure out what H is, because we know that the three angles of a triangle have to add up to 180 degrees. We also know that angle P is 65 and angle K is 61, that's given. So we can subtract those two angles from 180 to get the measure of angle H, which is 54. So let's go ahead and put that on the triangle. So now we have to figure out this segment K and this segment P right here. And notice that little k is across from big K and little p is across from big P. So now it's time to apply the law of sine, excuse me. So this is how it's done. We know that this angle is 54 degrees, so the sine of 54 over its opposite side, 25, is equal to the sine of 61 degrees over its opposite side, which is K. So we can actually figure out what K is based on this equation. The way to do that would be to cross multiply, as you see here. Then to solve for K, we just divide by the sine of 54, and remember that's just a decimal, so we can do that. So we divide both sides by the sine of 54, cancel things out, and we're going to type this into our calculator. So 25 times the sine of 61 divided by the sine of 64. So if you do that, you get approximately 27 meters. So let's go ahead and put that in for the segment K. So now what we need to do is figure out what P is. So in order to do that, once again, we set up the law of sines. So we know the sine of 65 over little p is equal to the sine of 54, which is big H, over little h, which is 25. So that's this ratio right here. I'm using the law of sines. Once again, we cross multiply. We divide both sides by the sine of 54 to get this expression right here. Cross out the sine of 54, and this is what P is equal to. So 25 times the sine of 65 divided by the sine of 64. So we can punch that into the calculator and get that it's approximately equal to 28 meters. So let's go ahead and put that right in here for segment P. So as you can see, we figured out the three angles and the three side lengths of this triangle using the law of sines. Okay, let's work on one last example here. So here, this is an example of angle side side, so we don't know, we can't figure out what one of the angles is by using the triangle sum theorem. So because we only know one angle, we have to use the law of sines right off the bat. So this is how it's done. Suppose you want to find out this angle D. We know the sine of D over 17 is equal to the sine of 88 over 34 using the law of sines. Notice I didn't use F because we don't know the angle, or we don't know little f, the opposite side. So we used D and E. So we cross multiply to get this expression. 34 times the sine of d is equal to 17 times the sine of 88. We divide both sides by 34 and we get this expression. So in order to figure out what d is, we have to use inverse trigonometry. So if the sine of d is equal to this number, that means that d is equal to the inverse sine of that number. So this is what you're going to need to type into your calculator. And once you do that, you'll get the angle for d, which ends up being 30 degrees. So let's go ahead and put that on the triangle. Okay, so we know two of the angles, 88 and 30, so that means we can easily figure out what angle F is by doing 180 minus the two angles. So that's going to be 62 degrees. Let's put that in the triangle. And so lastly, what we need to do is figure out what little f is, the side length across from angle F. So let's label it little f, and we're going to apply the law of sines in order to do that. So here you have the sine of 62 over little f equals the sine of 88 over 34. I could have also used the sine of 30 over 17. That would have also been fine. But so we cross multiply and we get f times the sine of 88. These two multiplied together equals 34 times the sine of 62. And remember, we're trying to solve for f. So what we do is we divide both sides by the sine of 88 to get this expression. We type this into the calculator and looks like that equals 30 kilometers. So let's go ahead and put that in the triangle. And as you can see, we've solved the triangle. We figured out all the angles and all the segments of this triangle. So that's how to use the law of sines.